Okay, so a lot of this stuff you guys know, but again, we're just giving names to things. One thing that you're going to find is, in geometry, they're going to give you all kinds of different stuff, and you've got to decode what the stuff means. So how you say things, important. How you write things, important. How you abbreviate things, really, really important. So if you mean a ray and you write a line, your answer's wrong. If you mean a segment and you write ray, your answer's wrong. You have to make sure that you're meticulous with the small details in this class. So you tell me in your own words, what is an angle? Wow, really?
Like 2 lines like in a sec and
Yeah, like if you did like this, is that an angle? Yeah. So it can be 2 lines, 2 rays, 2 whatever that intersect to create angles.
A bended line.
A bended line, not really what we want.
With the corner. Short term. I think I'm right.
So I know I put the definition inside whatever it is, but 2 lines that can intersect to create an angle that we can actually measure. We've done these before. You all talk about acute angles, right angles, straight angles, obtuse angles, reflex angles. We talk about all of those different kinds of things, right? Okay, so let's talk first. If I have just 2 rays that come together like this and they form a little bitty angle, what do we call him? He's acute. Oh, he's acute. Acute little angle. Acute angles are anywhere from, what are they between? So they're 0 to 90 degrees. They have to be in between. They can't be 90. They got to be in between that. What if it looks like this dude and they are perpendicular?
Right angle.
That is right angle. A right angle is always,
90 degrees.
whoops, I'm losing my mind. I almost put 180. Okay, what if I have one that's a little bit fatter than a right angle? We call him obtuse. Can be greater than 90 degrees. What if I have a dude that's completely flat? What is he called?
180 straight.
He's called straight. And he is always worth 180 degrees. I can tell you more times than not, you're going to be looking at straight angles until you are blind in the eyeballs. And I'm going to ask you a million times, what do those 2 things make? And I always put my arm out like this. Anytime you see that, you should be thinking, straight line, 180 degrees. If we have something called a reflex angle, I don't think they do this right away, but they look really similar to other stuff, but they put this dude on the back of it that looks like this. And what that means is we're actually measuring around the back side of the angle, not the front side. He's called a reflex angle. He's anything bigger than 180. So this is reflex angle, and he is greater than 180 degrees. These are all good descriptions of different types of angles. Descriptions matter. What is a ray?
One part's a line segment thing, and then the other one goes on through.
He goes on and on and on and on infinitely in one direction, not in 2 directions. A line goes in both directions, right? A ray only goes in one direction. So he looks like this. He has a point and he goes on in one direction. Again, how you label things, highly important. If this is ray AB, then if I'm going to write it, I'm going to say AB, and it looks like this. It is going to point in the same direction. I have to list it exactly how it looks if I'm going to have it on the line. It's got to be perfect. If we have an angle and we talk about sides, what are the sides?
The base.
They're the things that come together. I'm going to say pieces. What is a vertex?
Point.
They're the corner where 2 of those guys come together. I'm gonna say point of intersection even between lines, rays, even, I'm just gonna say etc. So if you have one of these angle dudes up here, so let's say we have an acute angle, and this is A, B, C, which guy is our vertex? B is your vertex. This be your vertex. Amazing, none of this is new, right? Except for the bottom. If we talk about an angle bisector, think about what we talked about when we said line bisector. It means it divides it into two equal. So if we have an angle bisector, same thing. Angle bisector divides any angle into two equal parts. So if, and again, they're gonna say these things in some weird ways. So let's say we have angle A, B, C, and they tell you that BD is your angle bisector. So if BD is the angle bisector, that means this piece is equal to?
45.
Yeah, they're both gonna be 45, but these two guys are the same. The way that we usually do that, if you all remember, we give them the same marking. So they both have one little curvy do on them. And that would mean that they're both the exact same measure.
What's an angle bisector?
It divides divides one angle into two equal parts.
Okay.
So I'm gonna say divides. I feel like that's a lot of words, but it's really not. Everybody got this much? Sweet. So if we were to have, and this is not necessarily what you're gonna have today, but we still need to know what interior and exterior means. Anybody remember what the dude is called that cuts two parallel lines and creates angles? Yeah, perfect. He's our transversal. These guys are parallel, these guys are transversal. When you have angle relationships and pairs, in this particular thing, this is almost like a highway. So if we have, let's say this is, just to give you an example, I-64. So this could be I-64, which is east, that's going towards Lexington. And this is, and everybody travels this direction. If we're traveling that direction, where are we going? Yeah, I-64 Louisville, which is west. So this guy goes to Lexington, that guy goes to Louisville. Anybody know what you call the strip of grass in between all of that stuff? It's the median. It's in between the two. So we call all these angles on the inside the interior angles. So when you have angles that wind up on the inside, they are our interior angles, which is in the yellow zone. So all this stuff in here, these are interior angles. So what do you think you call the guys on the outside? These guys out here are exterior. In this particular figure, make all that a little bit darker. We have all kinds of angles. Let's say this is angle 1, angle 2, angle 3, and angle 4. These guys are all on the outside. So if we have to label the dudes on the inside, this angle right here, we could call him 5, 6, 7, and 8. The ones that are in the yellow zone are interior. The ones that are on the outside of that, exterior. Just means inside, outside. That's all it means. What does the word congruent mean? Means the same. You're gonna see that word a lot. Equal or the same measure. There are times when I'm really not a fan of this book. They go over several things, kind of like in your homework last night. You go through what a midpoint is, and then they give you these 2 points, but don't give you the outside point, and none of that is in the description in your, like the part of your textbook. It's kind of like that today. Some of the stuff that you're gonna do is, you're gonna label stuff and you're gonna label it correctly. Another part is they're gonna give you something like this. What do I call that dude right there at the bottom? Vertex. That was funny. Did you just say vortex?
Yes.
I love it. I love it. TXT. Might as well be a vortex. Everybody's coming together right there. RQS. QXS, 2x minus 2, QXT, what? XT is 125. You gotta love this. Okay, so this is the information that they're gonna give you, something like this today. First of all, just for poo-poos and giggles, what is this guy worth? 180 degrees. So they are giving you algebra. They're saying that this angle right here is 4x plus 1. This dude is, how do I set this up to solve for x? Whoa, 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 whoa. I did not tell you that SX is an angle bisector. No, no.
2x minus 2 plus 1 equals 1.
There we go. I like that better. We got to add both of them together and set it equal to 125. So you do this on your El Papel, and let's see if we come through to get the same answer in the end.
You have a calculator?
Yep, top drawer. What?
You did it wrong.
Oh, I did. That's a 6. I was like, man, that is off. It's not. So, once you solve it, you check your work against mine. Anytime you get an ugly answer, you really should stop. I obviously subtracted here instead of adding 1. I was a dum-dum. It happens. Does that tell me any of the angle measures? No. So what if I want to figure out what this angle measure is? Yeah, so I'm going to do 2 times 21, take away 2. So 2 times 21 is?
42.
42 minus 2 is? This guy right here is 40 degrees. Now, what do I do to figure out this guy?
Subtract 40 from 1.
Yeah, you can subtract 40 from 125, or you can do 4 times 21, add 1. 4 times 21 is what? 84? 84 and 1 is 85. Does that give me 125?
Yeah.
This is gonna be really similar to some of the problems at the very bottom of what your assignment is today. What you need to do is, let's all reflect back for 2 seconds. What does it mean when somebody says this? What does that actually mean? And don't somebody say M. That's not what that means.
I'm not sure what the angle of TX is.
Perfect. The measure of angle TXS. What number or what letter should always go in the middle? The vertex. So when you look at these and they give you stuff like this, I still use my pencil and like outline it with my pencil first. So when they say TXS, that means this angle right here, this piece. So if you have to like mark it for yourself, even if it's in your book and you have to like erase it later on, highlight it, draw yourself a picture, do something so that you know which one you're working with. The measure of angle means you're going to give me an actual degree somewhere. So if it wanted this measure, that would be 85. Based on this information, could I tell you what QXP is?
Yes.
She says yes. How does she know that she's correct?
Because of the inverse. Wait, hold on.
180 minus 120.
Yes. All of this piece and all of this piece together, I want this big guy right here. I want this dude. They all have to equal 180. So I could do 180 minus 125 and I could give you that big piece that's left over there on that side. A lot of students will look at that and they'll go, well, they didn't give me enough information. They do, you got to figure out what they really want. Now, if they ask me for this piece right here, QXR, could I figure that out? No. Can I figure this guy out right here? Nope. I can only tell you what's left over here with the whole piece, not the piece of it. Now, if they told me that XR was an angle bisector, could I figure out what either of those are?
Yeah.
Pretty cool. Sweet. Clear as mud?
Yep.
Yay. Oh, let me talk about homework first. So, turn in your book to page 50. That's it, my friends.